Uncertainty is built into nearly everything we do in medicine. For example, high cholesterol doesn't guarantee a heart attack. There is uncertainty there. High blood pressure doesn't mean you will get a stroke tomorrow. But we still treat these because the risk increases and we want to prevent harm before it happens. Radiation is again no different. So the logic is that when the risk is uncertain but avoidable, we act with reasoned caution, not denial of alarm. And for policymakers, I emphasize that uncertainty is a reason for prudent system development. Just like seat belts and vaccines, we act even when absolute risks are small.
Welcome to Frame by Frame, Rethink Imaging, a podcast by Imalogics. Here, we explore the intricate world of medical imaging, aiming to dissect the field and inspire both professionals and curious minds alike. I'm your host, Chris St. John. Welcome back to Frame by Frame, Rethink Imaging. Today, I am joined by Dr. Madan Rehani. Dr. Rehani is a professor at Harvard Medical School and the director of radiation protection outreach at Mass General and Harvard Medical School. Before that, he spent over a decade as the head of radiation protection at the International Atomic Energy Agency, where he helped shape the best practices for managing radiation exposure in medical imaging across more than 100 countries. Today, we are digging into a subject that is both technically complex, deeply human, and potentially a little bit controversial, which I'm kind of excited about. We're going to talk a little bit about cumulative radiation dose. Dr. Rehani, thank you so much for joining us today.
Thank you, Chris, for having me.
Yeah, and so before we really dig in, can you just give our listeners a little bit of a background on your career journey? I believe you began as a diagnostic medical physicist, but eventually led the International Atomic Energy Agency radiation protection of patients, so the IAEA RPOP program, influencing radiation safety policies. How did that career arc change the way you think about patient radiation protection as compared with the average diagnostic medical physicist in a hospital?
Thank you very much, Chris, for asking this very important question. In short, I will say it changed my outlook immensely. And this is a profound and important question. There are three components to it. Number one, as a medical physicist in a hospital, you deal with so many things, and radiation protection is very small part of it. So whereas in IAEA, in the radiation protection of patient program, my job was 100% on radiation protection of patients. So it's something like the PCP versus a cardiologist or a neurologist or a urologist. So can you really compare to, that is the generalist versus the specialist? So I suppose the difference is just obvious. So additionally, I realized that my decisions can affect millions, and I did indeed pursue my actions as if I am responsible for patient safety in several billions of exams and procedures conducted globally. Number 2 point, I took ownership of my patient safety program as a father of the program would do for his children, and in this case, billions of exams being performed in the world. And finally, I will say that this was a shift from building a CV to building a legacy, aiming for results that outlast the tenure. Thank you.
Thank you so much. That was very succinct. I appreciate that. In that case, working across so many health systems, you've seen everything from national dose registries to paper-based record keeping. In your eyes, what best practice for tracking or managing patient exposure abroad do you think the United States potentially undervalues?
Thank you. Firstly, I admire your question because it is not only showing openness to what is existing elsewhere, but also assumes that something is being undervalued in US. And that automatically answers half of the question. Our job at IAA typically involves dealing with less developed countries. So that is, in my language, we call them as Karam Bhumi. That is a place where all our actions of United Nations organizations go. But at the same time, we in these organizations learn from best practices in developed countries. Frankly speaking, when I was in Europe and I was part of the policy planning meetings of European Commission, I hardly ever got a feeling that radiation protection is against business of radiology. All roads in radiation protection would lead to making patients safer, and that's it. I wish it could be the same here. There are many publications that have shown that higher patient doses for the similar exams in US in identical settings. It's like McDonald's saying that the call for low calorie burger based on high risk in standard burger will hit their business. Or also the example of airbags and seat belts. Historically, auto manufacturers resisted mandatory airbags and seat belts. It was way back in 1970s and 80s due to concerns over cost and customer acceptance. Also, another example of our popular situation is warning labels. In the US regulatory culture often places emphasis on warning labels and consumer choices, while in Europe it tends towards preventive regulation and redesign. So EU bans many cosmetic chemicals and food types that are still allowed with warning in the US. So coming back to the medical radiation protection, I found that the radiation protection is pursued in most countries as a need, as a common sense thing, as something that is helpful for safety. Anything to strengthen radiation protection may evoke reactions based on practicality, economical sense, but overall not as something that will reduce the volume of imaging. So that summarizes the difference.
In 2022, you participated in a debate or a panel at AAPM titled "The Use of Cumulative Effective Dose and Educational Debate." I think that was it was moderated by Dr. Shamay, wasn't it? Yes, frequent guest and friend of the podcast here. But in that debate, you argued that dose tracking isn't about hitting a single numeric limit. If it's not like a stop sign number, what sort of insights should clinicians draw from a patient's scan history?
Yes, I think at the outset, let me put up this situation. That imagine a situation of a crossing on the situation of a traffic crossing with only the blinking green light. So you must have come across few such situation in practice. They are. Imagine this is not at a crossing with small traffic density or frequency, but in a setting of huge traffic like in big city. What will be the result? Obviously, mess. Is the advice of watch and go, then watch and go not known to those on the wheels? Even if there is a repeated announcement of this advice, will it work? Obviously not. So this is exactly the situation we have in radiation protection policy when it comes to the patient exposure. We have only blinking green light. That is, just we give whole power to the persons who are ordering the exams, that watch and go. Use your judgment and that's it. So not only that, we feel anything restrictive will stop a life-saving situation of an ambulance carrying a very sick patient. I mean, are we insane? Or we hate anything disciplining? Things don't stop here. If the resistance comes from drivers of the ambulance, then perfectly fine. But can you imagine this coming from traffic police? Oh my God. So impossible indeed, but that is the situation we are. I have deliberated this issue extensively in one of my articles published in 2021 in Journal of Radiological Protection, titled as Old Enemy, New Threat. You can't solve today's problem with yesterday's solution. So not only traffic light example, there is another better example also to give, and that is of the drugs, where there are again three levels. One, over-the-counter drugs. Two, prescription medicines. Third, scheduled drugs. Within the scheduled drugs, there are narcotics or those drugs where there is extensive record of the amount of drug has been prescribed and taken. So why are we only satisfied with only one blinking green light or only one type of system? So this is a very primitive system, and we need to learn from other systems where they have been much more advanced. I suppose this should be fine.
Yeah. And so to follow up and just play around a little bit with this light analogy, if you'll bear with me, would you say that there are like what in imaging or in radiology would you see as a yellow light or a red light?
For example, hypothetically, I don't want to imply that this is what it should be, but the concept should be there. For example, above 100 millisievert of dose or 100 milligray of organ dose, there is a reasonable great degree of acceptance that radiation risks are there. There is almost all national and international organizations concur on that. So one could put them in the scheduled category list. And somewhere down the line of few tens of, let's say, 30, 40 milligray organ doses to 100 milligray, one can have a yellow light. So these numbers can be debated and decided, but the concept should be there. We have a concept, just the doctor is supreme, he or she can decide, and that's it. Otherwise, the patients are going to die.
What do you mean by that? Either the doctor reigns supreme or else the patients will die. Are you talking about like patient voices not being a part of the conversation? I just want to get a little bit of clarity on what you're saying.
Yeah, if you see some of the professional societies, they always take any situation as an urgent situation. It should be like every vehicle passing is like an ambulance. If at all we think of anything on controlling radiation doses, there is a great resistance that, this is going to make patients refuse the needed exam. So this is always. Down the line, you may have another question where I will deliberate more on this. But we always come up in arms with resistance to anything other than what is existing in the framework of radiation protection, that there should be no dose consideration when it comes to the patient diagnostic imaging.
And so I do have one other follow-up before we get back to our other questions. You mentioned, let's say, 100 milligray. When you said that number, in your mind, were you thinking about that as a singular dose or as a cumulative dose over the years?
There is no scientist from the national or international organization who can give me an indication that a dose recurrent at different times, let's say 5 times in a year, that we can apply some correction factor to it. So the only way the scientists who have spent decades and decades of research on these topics, I have asked the best in the world scientists, chairman of ICRP, chairman of committee 1 of ICRP, that I have patients who are at different times in a year getting CT exams. How should I calculate the dose? They say the only way is to sum up the dose at different intervals, whatever it is. Then I say that we people are used to applying corrections in radiotherapy where a patient has got 2 gray yesterday and by today its effect is downgraded because of the repair process. They say that knowledge is available for skin reactions but not for the carcinogenic effect. So for carcinogenic effect, the mutations whichever have occurred, let's say some fraction of them have been repaired, even if large fraction of them have been repaired, their theory at the moment is even the small portion of unrepaired or misrepaired can lead to cancer. So it is not the question of volume, you need minimum so much volume of misrepaired or unrepaired. So as a result, there is no organization in the world, national or international, which has anything better to say but to sum up doses at different times. So it means whether it is at, your question was at a single time or a divided time. So we have to sum up and it means the same.
I do feel like to some degree there's an element of fear that comes into play, from the patient perspective, right? As someone who has not gone to medical school, as someone who is relatively new to the field of imaging, I've only been around for about a year and a half. I see these different narratives being spun, and I see, the element of fear in being worried about if you get imaged, down the road, you may or may not get cancer. But how do we make sure dose history becomes a tool for better clinical judgment and not a source of fear-driven avoidance? Are there safeguards or education that you'd want to keep in place to keep, the concept of cumulative dose from backfiring in any capacity or preventing life-saving care?
Chris, excellent question. And one that gets to the heart of how we turn data into wisdom, not worry. So cumulative dose history should function as a clinical compass, not as a guilt trip. Much like medications, for example, if there is a flag in the patient's medical record about allergy in the electronic medical record, it does not mean don't treat. It means pause, reassess, adjust wisely. So we need to integrate dose tracking into clinical systems in a way that shows not just raw numbers but interpretable risk tiers. For example, when you go for a blood test, you find in the lab tests there are normal range, low, borderline, one can come to know. So if we frame scan history as a patient safety tool, not a liability metric, we can transform fear into foresight. And when used well, dose tracking can empower teams to make informed and patient-centric decisions, not defensive ones. But we have to open ourselves. What happens whenever an attempt is made, there are people who will just come and put the roadblock instead of coming out with solutions or saying that let us sit together and develop solutions. They want to put roadblocks only. So that is not the way things can progress.
Is it fair to say that you agree that we need more information about cumulative dose? And ideally, it should be researched more to come up with a better, more thorough, more thought out approach?
Yeah, that's why the company like Imalogics or there are other companies who have created the dose management systems, they are getting popular and there is a more need for it. Initially, they were more popular in Europe, now also becoming popular in US. So that way, there is a more need of having these systems and opportunities to have the information so that information can be used judicially.
So I believe it was a May 2025 executive order directed U.S. regulators to re-examine the linear no threshold model that underpins most radiation risk estimates. So if regulators weaken or abandon LNT, do you worry about momentum to tracking and limiting, or do you worry that the momentum to track and limit cumulative dose will start to fade, or will clinical culture kind of keep pressing for lower exposure anyway?
Chris, firstly, my area of work in recent years has been relatively higher patient doses of few tens of whether milligray or millisievert. It is not going to be affected in any way. Secondly, do we let uh, faucets run unnecessarily or leave lights on when away from the room or prescribe antibiotics unnecessarily? Radiation is no different. It is basic tenet of life. For lower doses, think of when medication moves from prescription only to over the counter. That shift doesn't mean the drug is risk free. It just means the threshold for concern has changed. People still need to use it responsibly. Just like you won't like these tablets just because they are available without the prescription, you will go by the guidelines of use. Every time you will either ask the doctor or see the guidelines available on the medicine and go by that. So, clinical culture must keep driving appropriateness, use with or without the LNT. The clinical commitment to minimizing radiation exposure is unlikely to fade. That is because dose tracking isn't about theoretical risk, it's about avoiding waste, improving values, and respecting the patient.
I will say, though, just as an aside, there are some doctors out there prescribing way too many antibiotics. I will say that.
Human nature.
Yes,
There are
absolutely.
so
So, I mean,
humans are humans.
yeah,
So you can
don't I
develop
know it?
guidelines, you can develop regulations, but humans, those variability among humans remains and will remain.
Yeah, absolutely. So, I mean, how would you
Otherwise,
explain?
our forefathers would have solved all problems and we would not have anything to do.
Yeah, I mean, honestly, that sounds kind of nice, but problems, I'll keep solving problems on my end at least. How would you explain, kind of that scientific uncertainty to patients and policymakers without trivializing risk or causing alarm?
Uncertainty is built into nearly everything we do in medicine. For example, high cholesterol doesn't guarantee a heart attack. There is uncertainty there. High blood pressure doesn't mean you will get a stroke tomorrow, but we still treat these because the risk increases and we want to prevent harm before it happens. Radiation is again no different. Low dose exposure might carry a small risk. We cannot predict exactly who will be affected or when, but that is no reason to ignore it. So the logic is that when the risk is uncertain but avoidable, we act with reasoned caution, not denial of alarm. And for policymakers, I will say, I emphasize that uncertainty is a reason for prudent system development. Just like seat belts and taxes, we act even when absolute risks are small.
How would you respond to, there was the 2025 JAMA International Medicine paper, projected lifetime cancer risks from current computed tomography. I believe that study estimated that about 100,000 future cancers come from CT usage. And that article didn't just pop up in JAMA. I first came across it. It was sent to me on a People magazine link. Then I saw it on NPR. Then I saw it on NBC. And a lot of the reporting on this actual study, they were getting numbers wrong. They were talking about the number of scanners, that was wrong. Where and how people engage with this information and the context of it is really important. And do you think such massive population level projections actually advance the safety conversations, or do they potentially risk sensationalism?
Thank you for this question. Yes, large-scale projections like the paper you mentioned, which appeared recently, and it was widely covered by the public media, it can be useful, but only when framed properly. And we regularly see similar models in public health. For example, lifetime heart disease risk from cholesterol, projection of the diabetes burden from obesity, or cancer rates from tobacco use. So these estimates don't cause panic or should not cause panic. They help decision maker plan screening, prevention, and educational programs. The same should apply to CT risk models. When they are projected properly for future cancers, then the current scan volume, the goal isn't to scare patients, it is to guide smarter policies like dose tracking, appropriateness criteria, or alternative imaging when suitable. The key is how we present these numbers, and that is the key item. So like any population model, they are tools for system level insight, not personal predictions. So yes, they advance safety conversations which have resulted in, and when paired with education that avoids fear and emphasizes the context, they can be useful.
To pivot a little bit, but to continue kind of down this thread, right? Radiation workers have annual dose caps, but patients do not. Do you think a softer, looser kind of advisory dose budget, for lack of a better term, for patients could help clinicians think differently about imaging? Or do you think that could potentially create more confusion? I clearly understand that everything is so situational, right? Every patient is unique. Every case is unique. Every body is unique. And so I know it's a messy question, but how do you respond to this concept of a patient dose budget? That's the wrong term, but you know what I mean.
The yellow light, a soft advisory dose budget will help in pause and reassess, not stop. So, but as the cumulative dose builds, especially beyond 100 milligrade to a specific organ, it may be no harm in bringing concept of scheduled drug, which I have already mentioned. Again, we don't forbid them outright, but we require their regulated use and monitor the cumulative exposure. Such a framework could help clinicians think more critically about the repeat imaging without creating fear or denying care. It encourages balance, being alert to the risk, but not frozen by it. And with the result, with good communication and decision support, a soft dose budget can guide appropriate imaging, not confuse it. And that is what the patient deserves.
Your editorial titled "CT is still not a low-dose imaging modality," it argues that manufacturers could already deliver sub-millisievert levels in CT. I'm curious about what vendor-related actions do you think are just sitting on the shelf, and why aren't they becoming the industry default?
This is an interesting question, Chris. Let me draw your attention and the listeners' attention to a paper which we published in 2020 in the European Journal of Medical Physics. And the title of the paper was, "Is it possible to kill the radiation risk issue in computed tomography?" So I partnered with a CT technology guru from Germany. He is really master in CT technology, having spent more than 2 decades on working on technological aspects of CT development and those. And we had identified 6 factors which can be used by the manufacturers to further reduce the doses. Maybe I can take a minute to list them. Number one factor was more powerful X-ray tubes, thicker pre-filters in a filter changer. So this is not something which is available in the systems as of today also. There is something in the X-ray tube development, but still far from what is desired. Number two was the use of turntable tube voltage settings. There is this is also something which has been lacking, and it is lacking still. Then automatic exposure control, not only to include the MA modulation, which has been around for more than a decade, or rather I will say 2 decades now, nearly, but also for KV and filter thickness modulation. This is again something which is doable. Then adaptive bow type filters, and finally the other 2 points were photon counting detector technology and deep learning. Out of these 6, the 2 of them have been implemented. The photon counting detector technology has now been commercialized. We have a system in our hospital. Many other hospitals have also acquired, and we have seen in situations like chest CT almost 50% dose reduction roughly, and deep learning algorithms are also providing. There is one we have from one of the manufacturers, not from others. We are using that, but remaining other 4 systems, 4 possibilities have not been still implemented. Your question had also the aspect of why or not the industry's default. Actually speaking, whenever I have gone to conferences like RSNA, and I ask vendors, why are you not emphasizing the dose reduction now? You used to do many years ago, and every year in conference you will have a flagship motto to show how your system this year is better than the previous and by how much in dose. They say that nobody is asking us. So it is a question of the capability being there, but the pressure from the users is lacking. So that is what is not moving them. And some of these popular media things do create pressure. That is what they did in 2003-4. Unfortunately, the people, they become bad in the eyes of professional colleagues, but at the same time, their work and their contribution does put pressure on the industry. I have seen many of my very, very important papers which I felt could have made the impact on industry, but they did not, because I didn't go to public media. I remained within the professional media. So public media has its own appeal, but people like me, they want to avoid going to public media to put pressure. So coming back to the question again, it is a pressure which buyers put on the manufacturers. The moment buyers ask for it, the manufacturers will provide that.
To hear you say that the demand isn't there, because in my mind, I'm just like, wouldn't a vendor sell just tons and tons of equipment and make lots of money if they actually built one of these systems? Like, and maybe I'm just being naive.
Let me take you back in history. It was 1980s that WHO had developed a basic radiological system. So, because international organizations like WHO, IAEA, and UN organization, their area of activity is the developing countries. So, what they wanted is an X-ray machine which does not require the high power. It can be connected to a 5 ampere points, light points, and even when the light is not there in developing country, it should work with battery. So it should not, the movements of all the arms should be not electrically mediated, but person does. So they had given technical know-how to 5-6 vendors and signed agreements with them. Whenever the vendors were going to the sellers, they will never keep the brochure of this system in front. They will always be background. They will not be. So because the system will be cheap, it will not have much financial value. Only 500 units after 10-15 years, those donated ones, but not sold ones. So similarly, it is a question of how aggressively both sides are, both in asking and the other one in selling.
I want to be extremely respectful of your time today. And so before we wrap up and finish recording for the day, to the listeners, I'm trying something new. Maybe it'll stick around. Maybe it won't stick around. But I've got these 3 questions that I'm, saving for the end of the episode, slightly higher level, just because I'm so curious what our guests all have to say. And so, Dr. Rehani, question number 1, what is one truth in imaging safety that, that people do not want to admit that you see?
That cumulative dose to larger number of patients is a real safety problem.
Okay. And, maybe slightly along that line, and maybe too similar of a question, but what is one idea in radiology safety that you think we're getting wrong?
That patients with high doses are small in number and sick enough not to live long to suffer radiation effects.
Yeah. And so finally, if you could have your way with imaging in the US, what would you change if you were in charge?
I would aim at almost killing the radiation risk issue in medical imaging so that patients could undergo any number of imaging exams as needed for healthcare. It's not a fantasy, but doable and achievable.
Well, Dr. Rehani, thank you so much for joining us today on Frame by Frame Rethink Imaging. It's been such a delight to have you today. I hope maybe you'll come and join us again sometime.
Thank you, Chris, for having me. I really enjoyed talking on these points, and I believe your records and podcasts will create the impact you intended, or we also intend. So this is something which is very close to my heart, and I'll be happy to see the benefits reaching the patients. Thank you once again.
Thank you. We're, here at Frame by Frame, we are here to have a conversation. And that same goes out to the listeners. If you have anything that you want to respond with, if you want to come talk about this subject matter, you can find us online, shoot us an email. Dr. Rehani, thank you so much again.
Thank you, Chris. Thank you, Frame by Frame program. And thank you, the organization which has helped you.
Absolutely. Frame by Frame Rethink Imaging is brought to you by Imalogics. Here, you'll find engaging interviews with thought leaders, experts, and patients, sharing stories that showcase the transformative power of medical imaging. To discover how Imalogics is rethinking imaging in healthcare, visit imalogics.com. Be sure to subscribe to Frame by Frame Rethink Imaging on Apple Podcasts, Spotify, or wherever you listen. And from all of us here at Imalogics, thanks for tuning in.